So let's finish up question 3. We've already set up our primary equation, which represents the area of the piece of paper that we're working with here. Our secondary equation is based upon the area of the printed section of the page being 24 square inches. So we want to put these together, and we'd isolate either x or y in the secondary equation. I'm going to isolate x, could just as easily isolate y. And that means our area equation will now be y plus 2 times, we can substitute 24 over y plus 3. We're going to want to take the derivative so we can calculate the minimum, but before that I'm just going to go ahead and FOIL. Y times 24 over y is just 24, plus 3y, plus 48 over y, plus 6. And one final step of simplification, 30 plus 3y plus, I'm going to rewrite it as 48y to the negative 1. So next we want to do the derivative of this. So the rate that area is changing with respect to y is equal to 3 minus 48y to the negative second. And we want to find the critical numbers. So we want to know when this is equal to 0 or undefined. So 3 minus, I'm going to turn it back into 48 over y squared. And I don't love that y squared in the denominator, so I'm going to go ahead and multiply both sides of the equation by y squared. 3y squared minus 48. And now we can just isolate the y squared. Y is going to be equal to positive negative 4. We want to remember to do undefined as well, and this is going to be undefined when y is equal to 0, because we'll get a denominator of 0. So that means we have 3 critical numbers, and we could set up intervals now, or I've shown us that we can also do this on a number line. Some online videos will do that, so let's just throw them on a number line because we want to check the slope in between all of the critical numbers. Also, if we pay attention to what we're trying to calculate here, we're trying to calculate what value of y will minimize the amount of paper we need to use. But we also want to make sure that we have a printed space of 24. Well, y represents the width of that printed space, and that width can't be negative. In fact, that width cannot be 0, otherwise there would be no printed space on the page. So all we really care about is just checking to make sure 4 represents the value of y that will minimize this piece of paper. So we're going to plug these some test values into the derivative. So maybe we would do a prime of 1. That's going to be equal to 3 minus 48, which is definitely negative. So the graph is decreasing over that interval. And let's plug in 10. So a prime of 10, which is 3 minus 48 over 100. 3 minus something like 1/2. That's going to be positive. So that means that the graph is increasing over that interval. And that confirms for us that y equals 4 is the minimum. If we calculate y, it probably is useful to go ahead and calculate the x dimension of the printed page as well. And since the area of the printed page is 24, we know that x would need to be 6. And these are the dimensions of the printed page. So we just want to check that we have in fact solved for what the question asks. And we're trying to minimize the amount of paper that's being used, but the question does ask for the dimensions of the printed part of the page. And so that is what we have solved for. If the question had asked what are the dimensions of the piece of paper, then we would want to remember that the width of the piece of paper is y plus 2, or 4 plus 2, and that the height of the paper is x plus 3, or 6 plus 3. And so the piece of paper is 6 by 9, but the printed part of the page is 4 by 6.